Okay, so today I want to show some lighting, modeling of objects in Maya and prepping them for the kind of lighting that you'll do in Unity. So I'm going to start off, I'm going to create a cube as usual. In this case, I'm wanting to make this sort of reflective surface. So I want to make this like big plane of glass. And it's based off of an idea from an architecture class where they want to create a reflective sort of triangular fin shape, and part of it will let in light and the other part will reflect it, so it creates this sort of gradient pattern. So what I'm going to do, if I go to the top view, I'm just going to model this without really following the actual idea for the model. So I want to do, let's do 60-degree angle. Let's see, yeah, that'll work. I'm going to call this, I'm going to rename this, in the attribute editor, I'll just rename it reflective fin. And I'll assign a new material to it so we can have separate materials in Unity. So assign a new material, I'll make it a blend. I'm going to call that fin reflection. And I'll give it a color just to make it easier to tell what's what. We'll just give it this blue. Tone it down a little bit. Then I'm going to take that fin. If you look at it right now, it's set up, even because I've rotated, even though I've rotated, it's set up on world axis coordinates. If I want to change that and sort of move it around based on the object, I can just go and click on the tools for my transform widget, this thing, set it to object, and you'll notice that it snaps to work on the axis then. So now I'm going to duplicate that object and just separate it. Now I could make this by faces, but for the purpose of making things easier to select and changing them later, I'm going to go ahead and just make replicate objects for this. The inner part should be opaque, so I want to call this opaque fin. And I'll assign a new material to that. Oops. Assign new material. We'll make that a blend. I'll crank up the whiteness on it. And go ahead and call that fin opaque. I'll leave that for now. So now that I have these two fins, let me go ahead and make the third one too. I want to make the third one glass, so I'm going to duplicate this opaque fin, and I'm going to rotate that. So one of the things when you get this rotation tool, if you move with it close in on the widget, you don't get such precise control, but the further out you move, the more control you get in terms of microscopic rotational degrees. It's not like a whole pixel. I have a lot more fine control out here, like giving it a longer lever arm. So I'm going to go for that. We'll call this transparent fin, and we'll slide it into place just a little bit more. Normally there'd be some sort of cap or gasket on this, some way of mounting this, but for the purpose of this tutorial I'm just going to leave it the way it is. We'll apply a new material to that. So a new material, we'll call this one, make it a blend and call it fin glass. We'll give it a little bit of transparency. And we'll give it another color too. Glass usually has kind of a greenish blue tint to it, so we'll just go with that. So like you can see, there's semi-transparent on the object, a reflective side that's not really reflecting yet, but it will when we get it into Unity, and then an opaque part. So now that we have those, let's go ahead and just combine them. We won't combine like a normal mesh combine because I want to keep them so that I can edit them later. So we'll go into Windows, Hypergraph Hierarchy, and you see the three objects here. For some reason when I name them here, I must have named the wrong one, so we'll call this one Metallic Fin. There, that changed. We can select it here and rename it in the hierarchy if we want. This one is, it's not the glass isn't selected, so it's the opaque, so we'll call this Opaque Fin. And this one will be the glass. We'll call that Glass Fin. Not sure why it didn't take earlier, but for now. So we'll make the metallic fin the parent. We'll just select these two in the hierarchy. Accidentally select these two and then middle mouse and drag them over under the other. Now we have that metallic fin and it's the parent object. Now we want to, in the top view, go ahead and hide this. We're going to pull this out and replicate it a bunch of times. So Control D with the metallic fin selected, pull that out and slide it into place like that. We can select both of those, Control D. Whoops. Alright, so here's something to understand. When I drag select it across all of these, if you look in the hypergraph, I've got everything selected, all of the parts. If I just select the topmost parts and transform those, then they will move correctly. But if I select everything, it's like everything's selected, and when I drag it, each one of these children have their own transformation matrix based on their parent, so that when I move them in a specific direction, it's in an opposite direction, just to kind of highlight the point. If I select that and move it out, you notice how it busts it up. So just select the parent objects and then position those. Let's go to the top view. So another way to move this around is once you get to a point where you're moving a lot of these, you may not actually be able to see. So if I zoom in really close and I want to position things, I can't actually see the widget to move it. So if I select Channel Box tab over here, and then just click on one of the translation elements, in this case I want to move it on the X. Select that, and with it selected, middle mouse drag in the window. I'm moving everything, so I can set it up and move it into position. And then we'll probably do the Z, nope, and do that. I guess the Y. No, it would be Z. No, Y. And again, now I'm doing it on the world axis here. So, let's see, yeah. X, just have to kind of zoom in to get it in position. Because I'm using these transform tools, that's on the world axis versus me using the actual widget tool, which you'll notice isn't selected here, which would be on the object axis, the way I'd selected it earlier. So let's just position this. There we go. A bit. Doesn't have to be too perfect for the purposes of this video, but just to get it kind of right. Then you can drag select. Of course, if I do that, when I move them, they're all going to bust apart. So drag in the hypergraph and just select the parents and duplicate those. Okay. It's actually pretty good. I'll leave that. Same thing again. and duplicate. And then across. There we go. All right, so now we have this fin pattern going, so you can sort of see what I'm going for. This reflective gradient from this side and then transparent from that side. Let's do one more just to make it bigger so we can allow more light in. I'll duplicate them all, go to the top, and position those. Zoom in where I need to make the connection. And on the X, there we go. All right, so now I have all of those as a wall. I want to select them all and group them. So if I just select all the top and then edit, group. So I can call this fin wall. I'll name it the group. Rename fin wall. Close the hypergraph for a second. So there's that. Let's see. Now you'll notice when I created the fin wall, my transform is left down here. If I want to center that so I can position it relative to everything, I can do modify center pivot, and that'll shift the pivot here. If I want to sort of snap parts of these walls together, like build another wall or duplicate this and rotate it and put it together so that it kind of pieces, I can I have to select the entire group, and then you hit insert on your keyboard. So you have to have like a full keyboard. Hit insert, and you'll notice that my widget for the pivot changes here. If I set up here under the live object tools, I can make it snap to grid, snap to line or edge, snap to point, and snap to projected center, and snap to view panes, and then I can make an entire object live and just snap it to the surface of that. I want to snap it to the point, and I want to put it up here on, not on this one actually, I want to put it on this corner over here. So you just grab that center pivot and notice that it wants to snap to all the vertices on this object. So I'm putting it on this corner, and I want it to probably snap to the inside corner. We can always change this once we get it duplicated, but I'm going to make it go ahead and snap to, because it's going to end up lining up off of this. So yeah, I'll probably want to snap it to the inside corner. Once I've got that snapped on into position, I'll just hit insert, and now I can turn off my snap to point now. And now my rotational axis is on the corner of the object. So if I duplicate this and move it into position, I can rotate from that, like a hinge from that point. So let's go to the top view. We're going to make this straight. Like I said, if you drag the mouse out further, you can kind of line it up. Using the grid lines here to sort of make sure that it's straight. I'm trying to. So I need to rotate it a little bit more. And I'll pull this. There we go. It's pretty good. Close enough. Now I'll take that position and then move it up to the corner here for alignment. So this is glass, this is glass. If I want, I can turn on the snap to point again and position this so that it snaps off the point. So I was wrong. I probably want to snap off of the in the outside here. So I'll hit insert. I'm going to move this point to snap to this outside point here. Made the point live up here in the magnet tool. I'm just going to put that there and then hit insert again. And from the top, then I can drag to that point so that they line up perfectly. So now one of the issues here is, I can leave it like that for the purposes of this tutorial. I kind of like the edge that creates. It's not straight, but that's okay. Yeah, let's go with that. Let's see. So then for the purposes of finishing this out real quick, I'm going to go ahead and just make some boxes to create a roof, or some boxes, and then we'll import it into Unity. So I'll go ahead and create a cube, turn off my snapping, and I'm going to make this cube just a flat wall. We'll go ahead and apply that opaque material to it. So we'll apply thin opaque. Go to the top view and align that. So I'm just getting it sort of roughly aligned, and then I can select this face and drag that up to the top. Then if I go to, figure out where I'm at here. Yeah, the side, I select this side face. I can drag that, the width, and zoom in. If I hit F, I can zoom in on that point. There we go. Now, maybe I want to take this face and then, like the angle of the wall here, I want to shift it. See how I'm creating this trapezoid shape? I want to shift that a little bit to get it lined up. And then I can, since I'm aligning to the outside, I can just go ahead and insert an edge loop. Here's my, so mesh tools, insert edge loop, and I just want to create like a edge loop so then I can pull a wall off this other face, this inside face right here. And using my polygon tools, I'll hit extrude, W, go to the top view, just line that up. Yeah, that'll work. Now I've got a bit of an angle here, but that's okay. Let's grab those points, those vertices, and maybe we just bring it back like that so it's at a straight angle to the edge of the wall. And I can drag select those and go back to my top view and sort of line it up better, get it more perfect like that. So now we have a solid wall and some glass gradient walls. I'll go ahead and put a cube in for the ceiling and the floor. So create another cube, polygon, cube, pull it up. We'll flatten that out. I'm going to go ahead and assign that opaque material to it instead of making a different one. The idea is this opaque would sort of be like wall paint color, I guess, like a white wall. Alright, so now I can drag this face. Whoops, selected the fin accidentally. So go back to object mode, select that, and then select the face. And pull that out a little bit. Same thing for this one. And then I can pull it into place. Trying to create a little bit of an overhang here. Let's go to the top view. Make sure we're at the, yeah, it looks pretty equal. Okay. Looks good. Now if I select this face with the world axis turned on, I can just pull it out so I can create an overhang. And then this face going back that way. So that'll help me straighten out this edge. If I go to wireframe, because you can see it doesn't line up now. This should be a perfect trapezoid. But you can see my edge for this wall doesn't line up. So if I select that and select by vertex, I can then pull this out and get it lined up a little bit straighter. And then the same thing for this roof. Give this a little bit more of a lip. Alright, same thing up here. That's good enough. Alright, we'll take that object and duplicate it for the ground. And then that closes it off. So now we have this sort of box with slats for light and reflection. We'll play around with that in Unity to play around with the lighting and show you how to set up reflections and lighting and all that stuff. So let me, one more thing, go under my hypergraph again. We'll select all of this and group it. We'll call that building. With that selected now, let's go ahead and save this as save the scene. Let's call this building. Oops. What's going on? It's not giving it to me. Hopefully I didn't crash. So now that I've finally got the building saved, I've saved it into this project folder that I already had previously built. So for you would end up creating a new project if you haven't already made one. But basically when you export from Maya, we have the building here, and you just say File, send to Unity, All, or Selection in this case. And it'll open up to whichever, if you've set your project in Maya, it should open up into whichever folder you've set and just save as the FBX format. Then when you open it in Unity, it's going to go and change that so you see your building here. Alright, so now we're going to talk about lighting. We can take this building and just drag it into the scene. It may be a little small depending on what the setup in Maya was. I'm going to go ahead and create a ground plane. So under Game Object 3D, create a plane. We'll go to make sure that's grounded. Set it for 0. So now you can see we've got our building on a ground plane, and the world, the light, the way the camera Unity basic scene opens up is you get this light, directional light. Where is that? W, and hit F to center on it. There we go. So the whole thing's pretty small. We'll make it bigger. I'll select the building and scale it up. Just kind of get it to scale. And then pull that off to this. Then we'll make the plane bigger to kind of simulate a more real world size. And then if you take the light, the sunlight, you can see that you can change that on the fly. So we can rotate, see our shadows. What you want to do is figure out, like, if you're trying to simulate something that's relatively, it's going to be placed, or an architectural project that's based on the real world, you want to figure out, what's east, what's west. So in this case, this is the north side of the building right here. So I'm going to set the sun. So if I go east, that's going to be like sunrise. So if I get facing the building, I can basically line the sun up. And in the summertime, the sun will go straight overhead, sort of, depending on where you live. But I want to sort of simulate more of a fall or spring type, where the sun's a little bit lower on the horizon to the south, so that when it passes, you get this type of shadow cast. And you get the fin action going in the buildings in terms of blocking and casting light. All right, so we have this super basic sky set up. Let me get the sun sort of positioned more towards 11 o'clock. All right, so let's talk about lighting. The first thing we want to do is we're supposed to have these reflective fins, but they don't really reflect anything right now. And that's because when we set them up in Maya, they were set up for, make sure we're on the ground. So bummer. So I need to go back into Maya. This is a good way to show. So I've got this little gap between the base and the fins. All I have to do to fix that is I left Maya open just for that reason. I can go and select this plane and then just pull it up into the fins, and then File. Let's go ahead and save that, and we will export to Unity again. Send to Unity. Select all for the selection. Send to Unity, all, or selection. Building, export, yes. And there it is. So now Unity is going to go and import the building again. Notice that the plane moved up, or the box did. I can drop it down to the ground like that. Now we have our lighting fixed going in. It's nice and sharp. All right, so now we have to fix these materials so that they actually start to reflect. So the way to do that is when you import an object into Unity, like here in our assets folder, we have this object, but it's actually a prefab. You see that? But there's this little arrow here. If I click on that, you see all the parts that make up that object. Here's our fin glass, fin metal, and fin white material. So if I select those three and then right click and say extract from prefab, it will ask me where I want to put a materials folder. In this case, I've already put one in this museum folder, so I'm going to select that, select the folder, and it'll extract those materials out of the prefab and put them here in this folder, this materials folder. So now we have our fin metal. When I click on that, you can actually edit it over here. So the first thing I want to do is I want to crank up the metallic, since it's supposed to be metal, and I want to take the smoothness. Notice that as I do that, I start to get the reflection in the glass or in the metal. Let me fix the darkness on this. Maybe we want to go with something a little less, sort of more aluminum, maybe a little bit tinted. So now you can see I'm actually getting a reflection of the sky. So the next thing to do is to think, well, let's go ahead and add the reflection on the glass here. So now I have fin glass. It's set for transparent, but it has no metallics, so I can, or smoothness for reflection. So I can crank up the reflection on the glass, and then I'll see that in the object as well, or on the material for that. Which in this case it's a little bit dark, so let's go make it lighter. And we'll crank it. And the way you control transparency on this particular material is right here in the alpha channel. When you click on the color, you can make it less or more transparent. So So you can see, we can see out through that glass, but we can't see through the opaque when I go inside. So I'm controlling the smoothness on the glass and the metallic. So the metallic seems to control how much reflection, or actually, how much reflection. So this isn't like true BSR DF glass where you're going to get like a reflection that's going to change based on the incidence of reflection, unfortunately. But as far as I know, there's not a material like that in Unity, because that's a pretty costly calculation for a shader. But we can sort of fake this. So I'm going to leave the metallic at that, and it may be that I can get better metal or a better shader. So let's, instead of the standard shader, we can do a standard roughness or a standard specular. So maybe standard specular. Then I can actually control the specularity of the glass using the smoothness. So make it completely specular. Change the specular color, and which sometimes will change depending on what the glass is made up of. And then the actual transparency. Alright, so sunlight wise, let's check and see how transparent that is, because it should let the light through. There we go. Yeah, you can see it going in, though it's a little dark, and then that might be because there's no light inside. We can test that. Let's just put a little light in there. So game object, light, and we'll just do a point light inside. Try it now. It's not very bright. We can also make it cast shadows, and we'll crank the intensity up. You can kind of see in. It's hard to tell. Let's go. This is where you have to start playing around to try to simulate whatever your lighting setup needs to be. There's just too much reflection, I think, on that glass. So if we do, we want to crank up the metal, and maybe, nope, the smoothness doesn't affect it. So this standard roughness, maybe. There's two types of standard. There's standard metallic smoothness. There's standard roughness setup, which gives you, notice that I don't have any kind of like, the specular goes in the opposite direction, I guess. None of this seems to be having a major impact on the glass. Oh, there's two thin glasses. I'm editing the wrong one, that's why. Sorry for that. Yeah, standard roughness maybe. There we go. So we start to see the specular on it, and you can control the transparency with the metallic. So the more metallic it is, yeah, that gives us a little bit more control. Now the question is, how do I know if, okay, so this, you can check the specular against the sunlight here, and it should be like super specular. So depending on the roughness of the glass, which most glass is really smooth, that looks a lot better. All right, so we went with the standard roughness setup for the glass. Yeah, and you can still control with the transparency, the alpha. Put a little color on it, and yeah, that'll work. So metallic, if I go full metallic, I get no transparency. It basically matches the other. And if I take it to no metallic, I still get specularity, which is what you want on glass. And it looks like it also has some reflection, but not, it's acting more like glass. Because glass doesn't, usually it'll only reflect more when you see it from an extreme angle. If you're looking straight on, it won't have much. So that might be where we could actually, if we wanted to simulate glass reflection, we could control this. We could create a code based on the camera angle and basically alter this roughness so that it becomes more reflective as we go to the angle. But we won't worry about that for now. Okay, so we have our transparency. Now, the next thing we need to worry about is, right now it's only reflecting this skybox, which is what you're seeing, this blue gradient sky, which is procedurally generated and alters the horizon color based on the sun's angle, which is nice. But normally we'll have this in a real scene, so we're going to just go ahead and create some boxes for it to reflect so I can show you how to set up reflections. So if you go to 3D game object, insert a cube. We will pull that out here and scale it up. I'm just going to try to make like a fake looking building along the edge here. Like there'd be a road here, and we'll put like another cube. Well, let's go ahead and texture this cube. Alright, so you'll notice that cube there's a shadow getting cast, but there's no reflection of the cube in the reflection. Let me scale this a little bigger. Let me go ahead and texture this with, we'll make a new material. Actually, I've got this checkerboard material set up. I'll just drag that on there so we can actually see something different. And then I'll make a couple of these. Duplicate. So no, it's an ugly texture, but I'm just trying to set this up so you can actually see the reflected environment around it. This will be another cross street. We'll make this building bigger, but lower, like that. Yeah. Okay, so now, in order to get these reflections on the metal fins to reflect the buildings, we have to go and set up what's called a reflection probe. Because by default the material is only going to reflect the skybox. It's a kind of optimization for the game. Or we could apply a reflection skybox of some other material, but it won't reflect the actual environment. But if we want to capture the environment, if we've got people animating or something like that in here, we have to go to Game Object, Light, and Reflection Probe. And that will insert this little kind of a real-time skybox generator. That's a reflection probe. That's what it looks like. So what we want to do to capture reflections is to alter the outline of this bounding box, because it'll only reflect things that are within the bounding box. Anything outside it won't. This is another way of optimizing. So we select this little point-based edit mode right here in the reflection probe in the inspector. And then you can grab those points and drag them to capture the bounds of what you want to reflect. So in this case, we want to reflect the buildings and the sky. And, oops, select the probe, click on edit, make sure you select the right point. So what I'm doing is I'm editing the bounds, so I capture the reflection for that light probe, or the reflection probe, I should say. Now, the other thing, notice it's not updating, because in order to see it, we have to set the reflection probe type. Right now it's set to baked, which would mean we would bake it and it wouldn't calculate again, which is fine if we only want to capture reflections and we have no objects animating in the scene. The camera can still fly, but if we want to change the lighting or see that update in the reflection or have people animating around, we have to set this to real time. So now we can see the cubes reflected, And yeah, so that works good. You notice that it's a super low res reflection right now. We can do that if like our metallic, if we take our thin metal here and alter it, the smoothness. Notice if we go low, it's simulating like a rougher metal surface, and then we can use a low res reflection probe in order to save some generation, especially since we're doing it real time every frame. But if we want more complicated or more realistic looking reflections, we have to take the reflection probe. Right now the cube map resolution is set at 128. We can crank that up to like 512 and notice that it looks, you can actually see the reflections better. So we'll go and take our metallic fins and leave them smooth. And so you can see we're getting these reflections now on our building that so it's behaving the way, but notice we're getting this reflection here on the corners reflecting that way, but we're not getting this building reflection. That's because the bounding box for this probe is just set up to end right there at that corner. If I make it too big, if you try to make a reflection probe that fits the entire scene, the probe itself isn't going to be super accurate from this angle. So if I make one that's over here, if I scale it over here, the probe itself won't look very good. Let me move where the probe samples from to. So I clicked on this little transform target and then shifting the probe. So the idea is, since these glass walls are here, I can move this probe as close as possible to the glass to get a more realistic looking probe update. Now the other thing to think about is, like, I moved the probe, nothing changed in the reflection. That's because right now the refresh mode is set on wake. Notice now I moved it, and suddenly we get these reflections that start to look a little more realistic based on what you see when you rotate around like that. See? By moving the probe closer to the glass, I got a more realistic reflection, and you can kind of see that in the probe itself. So that's the thing, is like, make sure you put your probes in the appropriate point in order for the reflections to look as realistic as possible. Now, the other thing to think about is this refresh mode is right now it's set for on wake, which is when the game would play. Again, if you want to update this so that the something that's animating will show up in the reflection, you have to set it to every frame. Okay. Now we have to make another reflection probe for this side, and I'll show you how reflection probes blend. So if we create another one, game object, light, reflection probe, pull that one over here, and we'll set up the bounding box to basically capture this building and everything down the street, or pull that in, across. And it's okay if the probes overlap, because they'll actually blend to a degree. You'll only see one when you're in it from that main angle, but when you hit the edges, they'll kind of crossfade, and you won't really be able to see the difference. Okay, and then let's pull this in a little bit so we don't affect this fin, but we will affect the one on the opposite side. Now we can move the probe closer to the wall for the glass so we get a more accurate reflection. We'll set this one to real time and set every frame for the refresh, and then we can crank up the quality. So now we get this building reflected in the pin, or in the fins. And then if we see from this side, we get the building across the street behind us reflected in the fins. So it starts to work the way we expect it. And then we're getting, from this angle, we get only, notice it's a little blurred, and only on these three fins. but we see that reflection. Now, if we wanted to fix that, we can rotate the probe. That first probe, we can just rotate it so that its angle is more aligned with the wall. Actually, we may not be able to do that. It's strange that the bounding box will only work on the north, south, east, west. That's not good. They should make, that's really strange. They should fix that code. You could probably rewrite the object, because see, like you can see where our probe lighting, or our reflection probe changes right here, just slightly. There's a little bit of a fade based on the that render. The other thing is, I forgot to point this out. Right now it's doing this spherical reflection probe. If we set it to box projection, notice that everything lines up reflection-wise. It just looks much better. And that's basically capturing the reflections from these points. So it's projecting out into the world. So let's see if that alters our probe for this one. If we can move it to just inside. Yeah. So then you notice how as I move this box, the probe scale changes. And it starts to look a little better. Sort of capturing a reflection of itself, which is interesting actually. That's pretty good, because it starts to look a lot more realistic. The museum's actually reflecting itself. It's really cool. So yeah, box projection is definitely the way to go. We don't have to, let me see, I think it projects out beyond. Yeah, because see, then you can see the building in the far corner over there. If I move this, probably doesn't matter, but the reflection looks a lot more realistic. So let's do that on the opposite probe too. Set it for box projection, that little check box there. There we go. And does it reflect the museum? Yeah, cool. It looks really good, especially when you look up here and you start to see the fins reflected back on themselves. Now, partially that shouldn't happen from here. It'll happen here because you get the staggered angle. It's not straight. But on this one, it should just always reflect back out, which means this probe probably needs to be pulled in a little bit more. Closer. Till the museum starts to disappear. And you only see the recalculated. So now we're getting the reflection of the fins themselves in there. It's kind of cool. It starts to create this Gerhard Richter kind of effect. That's really nice. Now, whether or not it would actually look like that in the real world, that's the question. But once you can tell, like once you get this. So the other thing is to think about like where the probe is reflecting from. But once you get this, that looks pretty good. Sort of updates. Once you get the real world reflected in the scene, everything it'll look a lot more. The reflections will look a lot nicer. All right, so that's the reflection part. Now we have to think about the lighting. And this involves baking the lighting. So when you have objects in your game, if you want to bake lighting in order to capture like global illumination, where light bounces off of the ground and bounces back up onto the object, you have to set these objects to be static objects. In other words, they're not moving. So anything that's not moving should be set to static. So we'll make this plane. We'll set that to static. And notice as soon as I do that, I get this little update down here in the corner where it starts calculating lighting. You can control that in the lighting settings, but for now I'm just leaving it set to that. The lighting will take a long time depending on the size of your maps and how much you're actually calculating, and also too the density of your texels. So let's take a look at that real quick. If you want to see what you're actually rendering from a light map perspective, you can right click up here on the shaded window and look at this baked light map. And you'll see these little grid marks on objects. Right now, the only object that's actually baking is the plane because that's the only one I set to static. So if I go and I set my building to static and say yes, change for children, suddenly you'll see these, the building pops into the scene and it has its own grid assigned. And those are the texels for the building. Now, the thing to think about in terms of bounce lighting is you don't need, a little bit goes a long way. Like this resolution, I'm just rendering too much. It doesn't need to be this big. So for my building parts, so now notice I've got a bunch of groups and I've got all my fins. Each one of these has a light map. Basically, if I select all of them, the fins themselves, I can then change that light map. The main thing I want to look at is this scale and light map. I can save a lot of space and it'll change my render size in the window if I make this like 0.25. Notice that my grid for my objects got bigger all of a sudden. And that's actually a pretty good size. Somewhere like 4 or 5 feet per texel is a good size for, at least for testing. If you want to go super realistic later, you can crank it back down. So let's open up all these fins. This is where it gets painful because if these were all grouped objects, we could set it on all of them, but because we want to be able to make changes, if an architect comes and decides they want to change the building and then come and get it changed or have it automatically reflected back in Unity, we want to leave these groupings set up for now. So I'm just opening up all of my fins, not all of them because I've still got the other side, but and then I can select everything and set this to 0.25. Now, the other thing you'll notice is that my texels are sort of stretched long. They're not square, which is a waste, but that's because of the way these UVs are set up on this object in Unity. So let me go ahead and save this scene and save the project before I make any changes. Now if I go to Maya, so I left it open, and I select, using the hypergraph hierarchy, I select all of my fins by dragging this way. Yeah, I can miss the groups. So I've got all my fins selected. I can basically go to UV editor, and you'll notice I've got this box set up for my fins. I can auto generate this UV map again, so just automatic. And UV, go back to the UV editor. Hold on a sec. I lost my selection. So go UV, automatic, or let's do best plane texturing tool, see what happens. Oh, I have to select by face. So if I want to select all of these faces, if I just drag or if I right click, I'm only going to select one. If I want to select them all, I can right click and select face. And before I drag, click on this little option for the component selection. And then I'll drag, select all of these objects again. Sorry about that. Oops. And select these. Now if I select all these faces, I'm going to do it for the whole building. But notice I can select all faces. And I'm just going to do UV automatic. If I go to the UV editor, I'm still seeing some. Let's do this. UV best plane. UV automatic. There we go. So it went to project this plane, and you get an accurate projection. Notice that it's got that the roof has the angle. Let's do the same thing on the bottom. UV best plane. Oops. Select that mode. For some reason it's just wanting to select that one plane. UV this plane. Won't generate. Let's do it on just this one fin for now. Let's get out. Select UV best plane. Select faces to map. It's just selecting these faces. Actually, I can select them here. I select that object. Sorry. For some reason, my machine's acting a little slow. Select by face. Actually, I think I may be bogging down. I'm not sure. Let's hide this. Let's do this object, the wall, for now. Go back, object mode. Might be because they're all grouped, but let's do automatic. It says doesn't work with multiple objects selected. That's because it's grouped. So select that object. Yeah. And then we can select all of the faces for that object in the UV editor, like that. So they're only selected. Now we can do best plane or automatic. There we go. So automatic, and it lays out the UV maps for that object. Then we can select object mode again. We did it for the top. We didn't do it for the bottom. So we can do again in the UV editor, face, select by face. Then do UV automatic. It lays them out. Object, and we can do it by individual fin. We'll just do this one for just to illustrate the point instead of me going back. I should have done this on the originals before I went and replicated them. So we'll do select all these faces, and then do UV automatic, and that'll lay those out. Now, if we save, I'll save. This won't affect this will affect how texture maps apply to it. It won't actually affect the reflection map, but it will affect the lighting map. So it won't be so costly, and you can kind of tweak it a little bit better. So we'll save. the scene. We'll export. I've got to select everything again. And file, send to Unity, selection. And we'll do it on our building. Export selection, yes. And now if we open up Unity, we'll see it reflect. And you'll see by doing that automatic texture mapping, my UVs for this particular fin and for the roof and everything else got laid out square. So now I have more control. So if I select the building, let's see, which fin am I looking for here? Whoops, cancel. Let's just select them all. Set the fin count, the scale and light map to 0.1. Yeah, that looks pretty good. So then we can look at the wall. So its scale and light map right now is set to 1. We'll go 0.1. That's good. Still maybe even a little big. The roof, same thing, 0.1. And the ground, 0.1. And then we'll set the ground plane to 0.1. Let's see what that looks like. See how it says on this ground plane, it says object size and light map has reached the max atlas size. That's just a warning that it's clipping the actual pixels. So that means I can go smaller on the scale and light map. So we'll set it to 0.01. Yeah, that looks good. So for this ground plane, something like a 10 meter size texel is a good size. For anything that's fine like this building, you might want more. And I'll show you how this pans out in a sec. So if we go back to shaded mode now, to see how the light bounces around, let's go ahead and save our scene. So real quick on the lighting, when we bake, let me make sure the building is set for static. Yep. The plane is set. These other buildings should be set for static so that they show up and reflect light. Now if we go into the main thing is the directional light itself is only set for type directional. So there is no light that's casting or getting baked right now. It's all real time in terms of this mode. We set that to mixed. We could set it to bake, but then it would only be casting light based on baking. We want it mixed so it does real time and baking. So as soon as I turn that on, the baking starts again. So if we go into our lighting settings, this is what's happening, is it's baking this light map using the Enlighten plugin. And we're setting an indirect resolution, which is our indirect lighting is set for 2. And our light map resolution is 40 texels per unit. We can globally change these settings, and if we see in this baked light map size, by changing these, then this light map will get bigger. So if I change this to 20, notice that all of my boxes got bigger. So you can globally sort of tweak this down just to test your lighting very quickly. The one thing we're going to want to turn on is this final gather and set the ray count. The default's 256. We can see how that renders because everything we do here is going to crank up the time it takes for this thing to render. One of the other things that we want to do for the environment lighting is right now we don't have a sun source set for our environment. There's none light set here. We can drag our sunlight into that to activate that. Go back to shaded, and we're letting the lighting bake now. So this is how you go to play with lighting in the lighting settings. If you don't have it, like I've pulled it over and made a tab here, it's usually under Windows and Lighting and Settings. Just pull that up, it'll open up a pop-up window and you can drag it over and make a tag out of it. Once something's baked, the maps will show up here in this global maps setting, so obviously we haven't finished a bake yet. The other thing is that it's set to auto-generate, which will eat up your processing time. So I recommend turning this off when you work on a new scene, and then just hit generate lighting anytime you want to try to go and bake the lighting to get it to work. So the thing to consider, the thing that's going to eat up a lot of time in terms of baking, is the size of your ground plane and the relative size of your objects and their size in the light map. So that's why when we go and we selected all these objects, we changed their size in light map. The one thing I know we didn't do is we only worked on this first group. I don't think we worked on these alternate cubes. Let's see, we'll look at the inspector. Yeah, they were set, but I don't think I set the objects for this group. So I need to select everything in this secondary, because that's probably what's eating up our render time right now, is all of these are rendering really large light maps. See the scale and light map setting here? That's why it's taking a long time. So if I go and change, and you can also see that reflected in their baked light map, notice that they're still super fine. So we're going to open these all up and change their scale. Now, this is how you go and optimize your lighting if it's taking too long to bake. Real quick. This is just one of those things you get used to over time. It takes a while, but if you set it up, once you've set it up, it works. All right, so let's select all of these fins, and their scale and light map, we'll set them to 0.1. That's good. So hopefully that makes it bake a little bit quicker. We go back to shading, close that group, save, and save the project. So if we go back to our lighting and hit cancel and then generate lighting again, one of the things we can do if we need to see it quicker, just to show the effect of the light map, or global illumination, if it's not rendering fast enough because we have a lot of stuff that it's trying to calculate, we can quickly make kind of global changes here to get it to where it generates, and then we can check out the results. And then later on, when we're done with setting up the lighting, we can crank up the quality and set that to render. And the map, once the maps are baked, they're baked. So let's go ahead just to optimize this. For the final gather array count, we'll set that to 128. And I've got the light map resolution set to 20, which is fine. I can do maybe a 512 light map instead of a 1024. That might help speed it up. We'll hit cancel and we'll generate again. Let's see if it generates faster. So this is eating up processing time. You can still work in your scene while it's calculating. One of the things that might be slowing this down for me is having Maya open, depending on how Maya is sitting in the background. And the fact that I'm actually recording this video while I'm trying to render these light maps is probably slowing it down too. So hopefully it'll generate a little bit faster for you. But what we're looking for when it finally gets through calculating is it'll stop. When you open this global maps, you'll actually see generated maps for the objects. And you'll also start to see how anywhere there's bright light on an angle, it'll reflect back up into the building and actually start to bounce light onto the surface, which we're just not getting right now, but we'll see that in a second when this light map calculates. And the way you can control if you need more bouncing is you go to set your number of bounces for environment reflections here. You can crank that up. This final gather ray count is casting rays in the final gather, and then you end up doing this little denoising. Like if you have that, make sure you have that checked. Otherwise, it'll kind of give you a blotchy looking light map. And the cool thing is that if you do this type of lighting scenario, you can create light sources that emit using these materials. So like there's an option when you click on these materials down here, there's this emission option. If you crank that on, you can overdrive the color, the value that it's emitting, and turn an object into a light. So you could do a video screen or something like that, and that will actually bake light into the map. And normally you can't do that. And you also need to do this sort of light map baking in order to do what the next thing that we're going to cover, which will be real-time lighting. And I'll probably cover that maybe in a separate video, but we'll see. Let's see. So here's one of the inaccuracies that you're going to see is like this thing is reflecting the museum in this fin, but there's not a museum there. That's because the light probe is over here in terms of the calculation, what it's reflecting. And it may be that you end up creating this split multi-light probe where we just cross over in the glass here and you get one light probe for one part and one light probe for another. I don't know. We'll have to play around with that, but so it's still generating the light maps. So that's a good, that'll tell you why you have to do what I showed you in terms of trying to crank these light map density down and get your UV maps on your objects correct so that you're actually getting some finite light maps for those. One thing we could do to make this better is we probably won't have so much bounce light on the roof. So if I take these 3 cubes and maybe take them down to, see, object size and light map has reached max atlas size. It's a good indication that we're still too big. So we can crank them. Oh, well, no wonder it's at scale 1. That was one of those other cubes. So let's take it to like 0.005. And then on the building, these 3 cubes, the top, the bottom, and the wall, we can make those like 0.052. Yeah, I think it's starting to calculate faster. That one big box was what was killing me. Yeah, those look good. The bigger these texels, the better off we are in terms of the final output. See if I'm missing something. Yeah, as far as these boxes, those could be even smaller. Went up 2. Because they're just environmental. I don't care about the bounce lighting on them. I care more about what's going on this building, on the one we generated. Alright, so let's do that. We'll see how long it takes to generate now. Alright, so finally, after a little bit of tweaking, I realized I had to do some things to try to speed this up, that the baking was just taking too long. Part of it was that I was recording video while I was trying to bake, and baking runs off of the processor on your computer. So recording and baking together just is going to stretch it out for a while. But what I did, once it finally baked, and you can check out, like I've gone and we can see it in the actual baked light map. So I went and reapplied UVs across all the objects, especially the planes, which I probably should have done first anyway. Don't pay attention to all these reflection probes. I went and added those as well to sort of illustrate the difference and how to set up reflection probes for kind of more realism and the cost. So the first thing I did was I went and modified all of these fins. If you recall, I'd already modified this first one, and the other ones. So what I saw was if I open up the building and the group, let's just look at this first metal fin. And if you hit F in the keyboard, you'll be able to see it, is that, these fins have a finite kind of small edge. These little squares here, those were actually, based on the default mapping of cubes in Maya, those were like capturing, a lot more texels of light than these bigger surfaces were, or they were given equal amount. So as big as this flat surface was, I was getting the exact same texel count on these inner surfaces because they weren't UV mapped correctly. So I went into Maya and I select, so in order to map each one, because I didn't do it right the first time, and I'd already replicated all these, if you select just one of these and look at the UV editor, you can kind of see what I did. Originally it was this, T-square box map that usually happens on a cube. Let me go ahead and make one. I'll show you what that looked like. Let's pull that out. I'll just make it bigger. So I'm going to make this one sort of long and vertical like those. So the idea is, like with this thing, you can see the UV map here. With this thing now stretched in all kinds of ways, the UV map wasn't appropriate anymore. This was set up to be equal faces for a box. And because my biggest faces are this and this, that's just two of those, and they're not even mapped correctly. They stretch, and then all these others are a lot less, should take up a lot less mapping, and probably don't even really need it because they're so thin. So in order to, apply the right mapping, I would just select each one of these parent objects. If you select them all, it won't work. And then I would select face, select all the faces in the UV map editor, and then under UV, click automatic, and that's how you get your automatic mapping here. That would set them up so that, they're appropriately mapped, these small, so you don't get as many texels per map. So if I want to do that to this box that I just made, just to illustrate what it would look like now that I've stretched it out, if I say UV, or not UV, face, select all the faces, that selects all the faces on the box, and then automatic, you notice that its UVs are now laid out appropriately. The nice thing, and something I didn't know about, but it's sort of nice in Maya, is that if you look at this in the hypergraph, if I select, a group or grouping of these objects, because that group has no polygons, it won't map. It won't UV map. When I select that group, all of the edges show up, but if I try to map them, it'll only map the last object in the group selection. Whereas if I select this metal fin, in this case it's over here, if I select just the parent, because it does have UV maps, and just to sort of illustrate the point, let me take these UVs from these two and I'll pull them over here just to sort of shift them. So those will be in a different position. So now I have, the metal fins here and this opaque fin. Let me select the opaque, actually I'll select the glass and pull that in a different place. So now I have three different locations for UVs on these three different objects. If I select just the metal fin and drag, notice that by selecting the metal fin, I can get access to all of these faces. Then I can actually do my automatic mapping, and it maps them all at the same time. So I only needed to select each one of these individually. If I select the two and then do my UV faces automatic, actually let me just select one of these just to point it out. UV, and this gets frustrating. This is why you want to do it right the first time. So if I select this one and that one, I have two different objects with the three objects under it, or the two objects under it. If I select both of those faces and then do UV automatic, notice that it doesn't shift and I get this error. It says doesn't work with multiple objects selected. I'm not sure why it works for nested objects versus multiple, two on the same level, but that's the way it works. So if I select these faces, no, those are right. This one, select these faces, and then do UV automatic, it puts them in the right place. Now the other thing now is that all of these UVs are mapped out in the exact same location, which is normally fine, but if I actually want to put like a normal map or a texture, which I'm going to cover in this video, it's going to align exactly the same, which may be fine. That may be what you want. But you may want some variation across all of these different fins, because most likely in the real world they would be a little bit different. We'll show you what it looks like with them all aligned, and then we'll show you how to fix that. So yeah, I had to go and fix these UV maps because I was just rendering way too many texels on these little flat planes, and that's what was eating up the render time. It still took a while after I'd even fixed that, but once I had fixed those, it was a little bit more reasonable. So now when you see that model back in the engine, all of these are mapped out square. And if you look at the sides, they're just little parts of squares, which is what we want, because we don't want that many texels on stuff that doesn't really matter. So this is what the global illumination looks like in the baked light map editor. We look at it in shaded, you can sort of see where light's bouncing, hitting walls. I'm getting backlit on parts. It's not, I'm using a low res light map, so it's taking a little longer. You can see where these walls are self-illuminating on each other. I'm not getting much bounce light here because of the distance, but you can probably see it the most right here off of this edge where it's bouncing and lighting up the plane. And you can sort of see it coming off of the glass walls here. All right, so now with that light mapping baked, you can also see it a lot inside because it really opened up the inside. The inside was dark before. Now I'm getting bounce lighting going everywhere, which is what we want in architectural modeling. In terms of light hitting something and bouncing, lighting these back planes versus just having having them cast shadows and being in shadow. All right, so the other thing to notice is that I've got one reflection probe right here for this entire wall, this entire edge of planes. The other, I'm not sure if I had pointed out that you want to make sure that your reflection probe has this box projection set, because if you do it the other way, if you turn off box projection, you get this unrealistic reflection. It's sort of a spherical reflection. Still maps okay, but it's not accurate to what is going on across the scene. You can't see it, whereas if you turn on box projection, everything maps out accurately. So because I'm actually getting this reflected, and then one of these is I'm getting it from the angle and I'm reflecting this second building back here. Now if we do, I didn't like the way this one texture was working. It was working okay, but it sort of still looks a little fake because these planes, these mirrors should actually be reflecting the mirrors in front of them from certain angles, and I just wasn't seeing that. So like if you go to this angle, you start to see where it's reflecting the entire museum in the plane, right? And that's just it's impossible. It's interesting, but it's impossible. So in order to go for more accuracy, and that has to do with the reason it's reflecting the museum is that basically it's that if you look at this UV map, this museum is showing up in the actual map because of where it's placed. If I try to move it closer, I'll start to see the inside of the museum, and that's another thing. It's impossible. These should only reflect the inside accurately. If you were up close and looking inside, then you'd see a reflection of the inside. But right now, because of this, the way I'm trying to capture and get these outer buildings to align, it's not working up close. But if you want to go for some sort of more realism, you'll notice how these reflections sort of cascade and start to create what you would expect from multiple planes. And that's because I created a reflection box for each pane, which is super inefficient, but it sure adds to the realism in terms of the reflection. So I've got like a reflection box for each reflecting plane there. And what that does is it slightly shifts each one of the reflections as it should be coming off each one of these panes. Yeah, and these could probably be a little bit closer, but it also sort of allows them to just capture the next fin in front, which would block everything beyond that, and it starts to look accurate as you rotate around and see that you are catching the inside the way it should catch for the reflections. And the edge of the museum cascades the way you would expect. And the same thing with this building. So it sort of creates this card deck flip sort of effect. It kind of looks nice. What I did to sort of make it a little more efficient was, to remember before I had this thing set to update every frame. So if I have any animation going by, every frame it'll go and redraw this, recapture this reflection probe and recast the reflection. For these, I've got call it 20-something reflection probes. That's a lot of load for the computer to catch for every frame. So if I was going to do some animation in this, have a person walking by, I would want to set each one of these to be real time and then every frame on the refresh mode. But what I did to make it a little more realistic was, rather than catching them every frame so that it would probably bog down, I would just set it for on awake. And then if I decide to go and shoot some animation from this side to capture a person walking by, maybe I only turn, I might not show the person walking the entire length of the wall. I might only turn the ones that are going to catch the reflection on for real time so that I sort of save my processing power. So something to be aware of. Those are the ins and outs of the limitations of the way these reflection probes work. But you can see you can get some fairly good realism. Oh, another thing I did was I left the resolution for the cube map that's generated at 1024 on the end one because I was wanting, and also sort of changed its shape so that I could get this reflection of these buildings more accurately. But then for these, I left that one at 1024 too. For these, I set it to 512, which will allow it to generate a little bit faster. What else for lighting? Oh, yeah, the normal maps. So one of the things that bugs me about these reflection maps is these planes are sort of perfect right now, and if you look in the real world at skyscrapers, so let's Google that. Let's try. Skyscraper window glass. Good images. So you'll see, these are actually sort of showing perfect, but here's a good example, and it's on a curved surface. Here's a better one. Except you can't see them at the highest res. But what happens is that wherever there's slight variations in the way the glass looks, in the actual shape of the glass that warps the building a lot. Not much on a skyscraper, but some architects actually go out of their way to sort of emphasize that and create sort of a noisy plane, sort of like what you see here. And if you ever see these flybys, here's a good example. If you ever see the flybys, there's little variations in distortion in terms of the glass that cause the image to sort of get tessellated. And you just don't get that in this super flat reflection plane that we have going on, but it's pretty easy to create that effect. So what I'm going to do is I'm going to apply this Windows normal here that I've gone and created. It's a normal map. And basically what I did is I just created a noise texture and then offset grids of or squares of the texture to create this pattern so that each one has a slightly different angle. What these normal maps are is they're RGB images where the red, green, and blue each control sort of a normal direction on an object. So you want to save these as a PNG or something uncompressed because the number of colors for each channel counts. in terms of having accurate maps. If you try to save it as a JPEG, depending on the quality level, sometimes it will, the JPEG artifacts will show up. So we'll take this Windows normal. If I go into my materials and find, let's see which one. So I'm using this fin metal. So if I go into materials, and then in the fin metal, there's this normal map right here. So if I just click on this target, I can't even remember what that was just called. So let's see, Windows normal. So if I click on the target and just type Windows normal here, there it is, and apply that, you see how suddenly I have this variation in the mapping. Now, it's variation along the top, but each panel is taking the exact same part because of the way I did the UV maps in Maya, where I was pointing out that each one of these fins, the UV map, the UVs were located in the exact same place, like that. They're all at that point. So basically, those are all sampling this little slice of the normal map, this little square here. So every one of these has the exact same part applied. And you'll see it on this side too. So there's the distortion there now, and if you get up close, you can kind of see it really nice. It just looks more like glass that way because you get the warping across the surface, and it makes it look more like kind of wavy glass. And it just kind of dresses the image up a little bit. But because they're so perfect, and that might be the case because we saw in skyscrapers that can kind of happen, but there's probably going to be some variation if we, in the real world, each one will have slightly different angles or different types of distortion because it's going to, that's the way the world works. So in order to do that, we can go into Maya, and what we'll do is real quickly, we'll offset each one of these just a little, not all of them. So we need to bring up the hypergraph, and we really only care about the metal fin. So what I'm going to do is I'm just going to randomly select, I'll select every other metal fin for now. Actually, let me go ahead and select by face. And then if I randomly select, we'll see if I can actually pull this off. Randomly select each fin. Probably doing this on the wrong side because it's less noticeable here as opposed to the other reflection map. But anyway, we'll just do those for now. And then if I select, so now I've got all of these faces selected, and I can shift them in the normal map just slightly. And maybe I'll select some here and just shift them that way. And we'll do this on this side too. So let me open up I'm not going to do all of them because I want you to be able to see the difference. So every other fin. So basically when I did that selection a minute ago and I checked this after I had set faces, it was basically setting it to component mode and allowing me to select all of these individual faces on the object, even though they're no longer selected. All the objects were selected, so I could offset them. Otherwise, I'd only be able to edit them one at a time. So, which could get slow. All right, so now if I take that, let me select the building, and go back to object mode, select everything, and export, send to Unity, all, or selection. So I'm in the assets. It's crashing like it was yesterday. For some reason I ran into an issue where after a certain amount of times or opening, maybe it was because I was recording video, I would open up this export selection and end up crashing. It wouldn't crash, it would just lock up Maya, like I can't get a response from the engine here. So let me go ahead and quit this. I can try to do it one more time real quick just to show you the example on the side I really cared about. So I'm going to go to Task Manager. I will end Maya. All right. Now I'm going to start Maya back up. Try this again, and I'll just do it. I'll make sure I save as I go, do an automatic save so I don't have to, hopefully, and I can also delete by type history, which can also save it some. So file, let's open the recent, don't save. I want to edit just these. Let's see, Windows, hypergraph. I want to deal with group 1. I'm going to go backwards so I can get these ones that are closer here. So this one, this one, this one. You know, if you wanted more variation, you could do every third and then do every other, so that you had 3 different locations. Let's try that. Yeah, like that. Go to UV editor, face. They're all selected. Make sure I have that. Grab them and pull them. Then, you know, another way we could do it is if we wanted to just make them all very different, you can polygons and then layout, and that'll lay them all out separate, but then they get smaller because it's trying to fit them all into the map. So we won't do that. We're going to keep them the same size so that at least the horizontal lines line up, and then we'll manually select every other one. Make sure I'm doing this right. Actually, those are all edited. Which one did I select before? I'd done this one. Let's make sure. Yep, so there. So it's every other? Nope. Somehow I'd gotten offset. There we go. I must have missed one at the top. Yeah. Select face, drag all of those and put them here. Now, if we select object, I want to edit, delete all by type, history. Normally I wouldn't do that if I was like a character or something, but for something where I don't have any transformation or deforming on it, I can go ahead and do that. Otherwise I'd delete all by type, non-deformer history. I'm going to just save the scene. Now I'll select, let's try selecting a different way just so I don't crash, hopefully. Select the entire building. File, export, or send to Unity selection. There we go. Select the building. Export selection. Yes. So it's exporting. And if I go back to Unity, you'll see it re-import. And now you'll see where there's slightly different variation on each plane. They don't match up quite as much as they did. I mean, every third one does, so you can sort of see where at a certain angle they'll sort of line up. But it's a way of offsetting them. So the other way that you can control this on the material is select that metal fin, and in the fin metal we can play around with the tiling. So we may want to like double this up just to scale it. So 3 and 3 to give it more variation. It starts to get really noisy there. Kind of looks like the kind of machining you would see on tables and walls in the 1990s. Right now I've got the normal map amount, like the default would be 1, which would make it super noisy. It's almost too much, and that depends on the strength of your UV map. So if you just crank the intensity down to like something a little more reasonable, you can actually control how much noise is added to the metal. So maybe 2. Maybe I just want to stretch it this way, so I'll just go 1 on the X. No, I like it 2. You can also offset. Make it 3. I want to get one of these splits down the middle. Now it's not going to be down the middle because I've gone and offset them in an irregular way. I didn't know. It's not going to line up on every one, but that's okay. That kind of adds to the variation, because you can see like this one has 1, 2, 3. This one's 2. This one's 1, 2, 3. That's different, and then it repeats the pattern on the third one. But that adds a lot to the variation too. So, kind of like that in terms of the way the specular hits. You get this traveling kind of water gradient across the metal from the light. And obviously in a more detailed environment, that's going to start to look a lot more realistic too. All right, so that's the basics of lighting baking just for non-real time, and just to kind of give you a hint about how we would go about lighting a real-time object. And by real-time I mean something. So let me add a 3D object cube here. So by real time I mean an object that might move in the scene. Right now this object, it's not set to static, and I don't want it set to static. I want it to be real time because I might animate it using the timeline or something like that. But it won't pick up this baked lighting because there's no way for it to, it's not been baked. You can't bake it if it's not static. And it wouldn't make sense for me to bake it if the thing's going to be moving, because basically it'll move outside the light that it was baked for, and it won't make sense anymore. So in order to create like a real-time sampler of light, you have to go and create under game object light and a light probe group. So sort of like a reflection probe, you end up creating what's called a light probe, and they sort of look similar. But the way a light probe works is that each one of these little spheres is a sample of light in space. And as this object moves through those spheres, it will kind of balance out the samples of light. So you might want, like, you want objects close. Let me select this. So let's say the path of this cube is going through this. We're going to make this width. I can duplicate these selected probes and then pull those out to kind of like transfer from here. Maybe I want something a little bit higher, or maybe even one that's halfway in the middle because it'll catch more in the ground. Then I'll duplicate those. Something like that. Yeah, it looks pretty good. Let's pull these a little bit lower. And actually I want them right above the ground. Then, depending on the lighting, the way the lighting changes, I want to duplicate them along the path that the object will animate. So we'll create this array of objects going this way. Now this looks like it'd be relatively inefficient, like I'm adding a lot of samples, but this is far more efficient than baked lighting because it's only sampling points in space, and it's only sampling a couple of points versus counting all the texels on every single surface. So it's like the way Industrial Light and Magic captures light probes in their scenes. You're basically doing the exact same thing in your virtual space. And I'll show you how it works. Duplicate one more. I kind of want, because you've got a variation in the way the light's coming from here versus getting in shade here. Then I'll put one out here. We could take it around the corner if we wanted to animate it around the corner. If we did, we'd want to have something like that, and so that we could sample along that far wall, and then something here. And I'll put one further out. And we'll take these and duplicate this way. Now I may be kind of oversampling here because how much does the light actually change here? But you can always go back and delete too. I'm just sort of putting up a light probe group to sample the situation. All right, so now that I have these light probes in here, and this cube is set, cube here, my light probe group. So the cube is set to get its mesh render is set to capture, because it's not static, capture these light probes, blend probes. There's another option, which is like creating a light probe group that travels with the object, sort of an array of probes around the object. I won't get into that on this video, but you can use that for kind of larger objects that need more sampling related to the actual objects, like a giant Godzilla type creature or something like that. It would work better. This use proxy volume would work better than the blend probes. But for small objects, blend probes is probably your better option. So we have the mesh render, and then this anchor override is basically, if you have like a complex character, where the probe samples from in terms of location to this. Because if you look at this mesh, it's not married to the light probe group yet because we haven't baked it. But once we do baking again, so I don't have light map static on, cast shadows is on, everything else looks fine. All right, so now if we do bake, hopefully this won't take forever. So you can see how it's cranking through the jobs, and I've got this like 90-something jobs, and that's because of all the reflection probes and all the different objects that I have over on the other side. Okay, so the light map finally baked, and you can see a huge difference in terms of this cube. You'll also notice that once these light probes are baked, that as you move the cube through the light probes that affect the cube are activated. So you get this real-time lighting based on the baked lighting coming off of the scene, and then when this moves, you can see where it transitions. It moves into the light. There's a nice little fade. You can even see the difference in the light probes. So these are dark and this one's light. So as it moves through this polygon, it transitions from dark to light. And same thing. Now we're outside the probe. So when the probe is done, or as the probe ends, whatever the lighting is as the object leads, it kind of sticks. Notice how it's tied to that last probe as I move. Until it hits another light probe group, it won't change. So that's something to consider. as you're setting up your light probes for real time. And the cool thing is like if there was a color effect, if there was a light emitter or an object that was set to emit glow or something, that would get picked up by these light probes as well. So that's pretty much the real-time baking, the real-time lighting, and the light probes, or the real-time and the baked lighting in this tutorial. You can kind of see starting to pick up the green bounce coming off the reflector there. So it works really well. All right, hopefully that was useful. Next video we'll probably cover more use cases for normal maps and materials and things like that.